this solution of this equation gives two sets of curves. So now what is flow line? What is equipotential line? Just now I explained you flow line. You know that the path along which water particle flows is represented by streamline, also called flow line. So equipotential, the line joining the points of equal head is called equipotential line. Now characteristics of flow nets. So the first very important characteristic, as we already discussed, flow lines and equipotential lines are smooth curves. They are not straight lines. Second, very important point, flow lines are perpendicular to, or flow lines are perpendicular to equipotential lines. So that means they are going to meet orthogonally. Next, no two flow lines are equipotential lines should intersect. Next, that means what I will show you, don't worry. Next point is very important, that is flow field is approximately square. This is very important for us, approximately square. That means you see this L by B is approximately 1. L by B is approximately 1. L is approximately B. L is approximately B. So these points we should keep in mind while we are drawing flow net also. So when you are constructing flow net, please keep these points in your line. What is the basic use of flow net? So let me tell you, the first one is to quantify seepage loss. Second one, to calculate head at any point. Calculate head at any point. This is very important. And another thing, we are trying to expect uses of flow nets. So another thing is also very important, to calculate exit gradient. And moreover, to calculate factor of safety against piping. This we all know, ICR by I exit. Just like I told you what is I exit. Now, can anyone tell me now what is ICR? So G minus 1 by 1 plus E. I think most of you are ready to answer. Then there is no issue now. So these are the basic fundamental, what I say, application of flow nets. So we have seen properties, characteristics. So we have unique characteristics of flow nets. I can show you upstream head here. And this is the ground level dredge line. Now let me draw this ground level, and it is my duty to show you downstream level. This is downstream. Now anyone can tell me what is H now? You can speak now. What is H here is? H here is. So that means this color may not be impressive. Let me change the color. This is H. Can anyone tell me upstream head minus downstream head? This is the difference of upstream minus downstream. Now the thing is, here you see, let me tell you, it's very important. So this is impervious layer. The same thing I would like to say that for Polavaram, they found rock at 20 meters. They found rock at 20 meters. So now this is what I call impervious rock, impervious stratum. Now the question I will tell you, actually, it is very important to tell you what we are going to discuss. See, now my job is I want to calculate seepage loss. I want to calculate seepage loss. ఇప్పుడు ఇది గ్రౌండ్ అండి, ఇది గ్రౌండ్, ఇదంతా సాయిల్, ఇదంతా సాయిల్. నా థింగ్ ఏంటంటే ఇక్కడ ఇది కే పర్మిబిలిటీ ఆఫ్ ది సాయిల్. దిస్ ఇస్ ద పర్మిబిలిటీ ఆఫ్ ది సాయిల్. నౌ మై ఇంట్రెస్ట్ ఈస్ ఐ వాంట్ టు క్యాలిక్యులేట్ సీపేజ్ లాస్. ఈ వాల్ కట్టాను, ఇప్పుడు వాల్ కట్టినప్పుడు ఫ్లో మారుతుంది. ఫ్లో ఎలా మారుతుంది? ఇలా మారి ఇలా వస్తుంది. Now I want to calculate seepage loss. So for that I need to draw flow net. So see the way I am drawing the flow net. All of you please see carefully. See the way I am drawing the flow net, please, all of you. So now you can see now. Now you can ask me, sir, you are saying it is flow net. You are saying flow net. Is it really flow net? Yes, it is flow net. Why I am trying to say like that? You see here, while I am drawing, the way I have drawn, you see flow line. If you see my flow line, here you can see FL1, FL1, flow line 1. What about this one? FL2, FL2. Now someone can ask me FL3, FL3. So here these are the streamlines. I have 3 streamlines. Okay. So now let me discuss about EL1. Okay. Now it is time to discuss EL2, EL3, EL4. So this is about the equipotential lines. EL means equipotential, FL means flow line. I will write here, EL means equipotential line, FL means flow line. Now you see, if you observe here, see the way I have drawn the figure. Can anyone, you see, if you observe clearly the way I have drawn the figure. So can you comment now? Can you comment? Have you observed that equipotential line and flow lines are
mutually perpendicular
to each other? It is very good. So I must appreciate you. And also, while drawing the lines, you might be observed. It is not actually. So I'm not trying to praise myself. I'm telling you, while drawing this figure, lot of confidence and whatever we believe. So whatever we believe, we should retain that. So here you see, I believe some fundamental things. Here I believed all these things. You see, flow line and equipotential lines are smooth curves. Here you see, I never attempt to draw a straight line. So you might be seeing the way it is just like an artist who is trying to prepare one drawing. So the same way you see, they are smooth curves. They are smooth curves. Now the thing, they are perpendicular to each other. They means equipotential line and flow line. Here you see flow line. See flow line 1, flow line 2. So like this flow line 3. Please observe now. Now what I would like to tell you, see here you see why you are not drawing the line beyond this. Can anyone tell? Someone can tell me why you are not drawing one more line. So if I am interested to draw the line, what is happening now? It is trying to enter into impervious stratum. If it is impervious stratum like rocky soil, rocky strata, how can I expect flow through rock? Are you getting what I am saying? So, and also one more point, as I already told you, see, while I am drawing flow line, see, I am going in my own direction. I am not trying to interact with others, intersect with the other flow line. See, each flow line have its own direction of flow. Just see. So I am not attempting to draw like this. So this line is going on its own way. You just see now. It is not trying to intersect the other line. So I am very sure whatever I am drawing. That's one more point. See, if you observe each flow field, someone can ask me, sir, you tell me, you show me the 4 flow field. I am ready to show. Here you see, this is flow field. The space between two consecutive flow lines and equipotential line is called flow field. Flow field. See, if I observe here, anyone can comment what is the shape of the flow field? What is the, for example, if it is length, if it is width. So what is L by B? Can anyone comment now?
One, sir.
Quantity of seepage loss. So whenever I want to calculate seepage loss, you might be given answer also. That's its law. Velocity of flow is directly proportional to idle. V is equal to Ki. Now discharge is equal to Ki into area. Now discharge per flow field, I can consider delta Q1. Now I can write K into delta H by L1. Now the area is B1 into 1. This is for one flow field. You can ask me, sir, how you got this equation? You see, I've considered one flow field. So maybe my hands are interrupting your visibility. Here you see, this is flow field. So consider this one. So now this is, you see, here you can see L. Here I can see B. So amount of water entering now. Okay. Now, and it is the amount of water coming out from this flow field. Now, can anyone tell me now? So now, K permeability Q delta H by L1. Why I am writing L1? You know, this is L1. This is L1. Now, why I am writing area? Area is B. B into 1. I am taking the other direction as 1 unit length. Now you see, what about delta Q2? So I have considered another flow field K into delta H by L2 into B2 into 1. Now it is very interesting to know what about L1 by B1? L1 by B1 is approximately 1. What about L2 by B2, which is approximately 1? So what I am getting at the end? K into delta H. K into delta H. This is for delta Q1, delta Q2. So what about all together Q? All together Q. Now all together Q is NF. How many flow channels are there? K into. I am calculating total seepage loss. Total seepage loss. NF means, can anyone tell me what is NF? Number of flow channels. So K into delta H. Now don't worry what is delta H. Delta H is equal potential head. Delta H is equal to H by ND. Total head by number of potential drops. Now can anyone help me now? NF into K into H by ND. Now can anyone help me now how to calculate Q? So I will go to the next slide. I think next slide means for me, I don't have that kind of facility. I need to turn the pace and again I have to adjust the pace. So Q is equal to KH into NF by ND. So I will explain once again. Q means seepage loss. Q means seepage loss. K means coefficient of permeability of soil. Coefficient of permeability of soil. What is H? Upstream head minus downstream head causing the flow. What is NF? Number of flow channels. ND, number of equipotential I will write without any hesitation, equipotential drops. You can able to calculate H minus N into delta H. Someone can ask me what is delta H? H by ND. H by ND. So now, for example, we want to calculate head here. Head at this point. Yes. Can anyone say? Now, N means, can anyone say? One, here one equipotential, two equipotential lines. Now, N is number of equipotential lines at that point. So here, now N is 2. For example, I want to ask this question. What is the head here? What is the head at this point? Can anyone tell now? N is how much? N is how much? So how many equipotential lines are there up to here? So that is the way we need to calculate head at any point. Now, exit gradient. See, let me tell you, exit gradient means delta H by A. Someone can ask me what is A? A is the average dimension of the last flow field. Here you see, A is the, this one is A. I will change the color because otherwise it may confuse you. I am taking care about you people. Let me select another color now. So this is A. This is A. So this is A. This is A. So A means the average dimension of the last flow field. Last flow field. Exit. See, you are writing exit gradient. So I want to tell you A is the average dimension of the last flow field. Okay, now I can write now. This is A is average dimension of the exit. Average dimension of the last flow field. Last flow field. So now I can able to calculate now the fourth one, which is very important, factor of safety against piping. Can anyone help me now how to calculate now? ICR by I exit. ICR by I exit. So now how to calculate ICR? You just now you told me G minus 1 by 1 plus E. I exit is here, don't worry. So I can able to calculate factor of safety against piping. Generally, we expect 3 to 4. Factor of safety against, if it is 3 to 4, so there is no piping failure.